Okay, hey everybody. So continuing on with lecture 7, actually kind of the start of lecture 7. The first video I posted was just a repeat of something I had done in class before. Now we're on to new material. I have a very small slide deck for lecture 7, and so these are just the slides from my slide deck. My plan is to make approximately one video per slide. The first slide, and so this is the lecture for Tuesday. You see in quotes it says October 16th. Don't come to class on Tuesday because I won't be there. These videos replace Tuesday's lecture. So the first concept that I want to talk about is dereferencing. And so there is a new operator called the dereference operator, which is the asterisk, and that will get the value at a memory location. And actually it does the same thing as the square brackets that we use with arrays. So let's write a program. So we'll have a variable x, and we'll have a variable y that points to x. Now, really important, the asterisk, star, whatever you want to call it, is used in two contexts. And so the first context is when we declare a variable. See, right here we're declaring a variable. If you declare a variable and use the asterisk, then it's a pointer. But if you use the asterisk in an expression, then it's the dereference operator. So if we say x equals 5, and then we want to print the dereferenced value of 5, of x, of y, the dereferenced value of y, then what this will do is it will go to the address that y is pointing to, which is the location of x, and it will print its value. So if we run this program, looks like I have a compile error, sorry. Then it says the value of y, if we dereference, if we look up what is at the address that y points to, then its value is 5. So I want to make a little chart here of what's going on. So let's print out some pointers. The address of x equals %p, and the address of y equals %p. And so let's look at the address of those two things. And then I also want to print the value of x and the value of y. Okay, so what's going on here? I'm going to make another shell. Is we've got at a certain location we have a value, and for each location we have a name associated with it. In fact, let's put the name first. So for the name x, the location, and I'm not going to type all this, I'm just going to type the very last thing, which is BEC, and its value is 5. For the name y, its location is BE0, and its value is all this stuff in BEC. Let me put some 0 x's in front of these so we know we're talking about hexadecimal addresses. So for what it's worth, it placed y before x in terms of memory addresses, and pointers take 8 bytes. Did I get this right? That's really interesting. You would think it would go at BE8. I'm not sure what goes at BE8. You know, again, we talked about this before, that the compiler has the right to place things at really wherever it would like in terms of the memory addresses. It typically places things bunched together. In this case, it didn't. I have some suspicions about why it did so, but I'll just say it didn't in this case. So even though a pointer is only 8 bytes, I would have thought it would have put it at BE8, and it didn't. Okay, so then what happens when we say dereference Y? This is 2 steps. Step 1 is, what is the value of Y? Answer, 0xBEC. And step 2 is, what is the value at the location of 0xBEC? And the answer to that is 5. And so for that reason, it's 5. So it's doing two things. It's saying, what's the value of Y? Well, that's a pointer, so go to that location, and then what's the value there? That's what dereference of Y is doing. And by the way, that's exactly the same as saying Y of 0, because it's doing the same thing. It's saying, go to where Y points to BC, and tell me the value of the first element of the array there. And the notion of treating it as an element of an array will be the subject of, I think it's 2 slides away. So one more thing I wanted to say about dereference before I stop this video is that it's not just a matter of using it to get a value. You can also set the value. So there's the notion of things that go on the right-hand side of an equal sign, and things that go on the left-hand side. And so, we could do this. We could say int z equals dereference of y. That's fine. But we could also say dereference of y equals 8. And if we do that, it is going to go and now change the value of x. X is %d. So when we compile and run this, now x has changed to 8 because we're dereferencing, but we're saying go to y and set the value of what y points to. So this address, BEC, because that's what y points to, set its value instead of being 5 to be 8. And that's why when we go and we print x, x is now 8, because by changing this pointer, we changed the value of the location it's pointing to, which is where x is. Okay, I hope this was helpful.